Alright, section 11.1d is the last section of, or the last time we're going to do section 1, and we're continuing to rationalize the denominator. Except today, instead of just having one term on the bottom of a fraction, we're going to have two terms, which complicates the process a little bit. If you remember back to chapter 8, when we practiced FOILing, these two things are called conjugates because they have the same numbers, opposite signs, 2 plus 3, or 2x plus 3 and 2x minus 3. When we FOILed conjugates out, in this case that would give me 4x squared minus 6x plus 6x minus 9. Every time we FOILed conjugates, these middle terms dropped out because they had the same numbers, opposite signs. In this case, that leaves me with 4x squared minus 9, which, if you remember the significance of this from chapter 9, was that that's the difference of perfect squares. 4x squared is a perfect square, 9 is a perfect square, and there's a subtraction in the middle. Well, so you're saying, what does this have anything to do with what we're doing now? If we have perfect squares, if we can create something that just has perfect squares left over, then we are eliminating the chance of having any square roots on the bottom if we can make everything perfect squares. So that's what we're going to do. We're going to use conjugates to eliminate square roots from the bottom if there are two terms. So when conjugates are two sets of binomials with the same number, opposite signs, and when you're multiplying them together, the middle term drops out and you're left with the difference of perfect squares, like a squared minus b squared, or 16 minus 9, or whatever it's going to be. You're left with two perfect squares that with a subtraction sign in the middle, which in our case would help us get rid of the square roots on the bottom. So here are some binomials that instead of variables have square roots. So let's FOIL these conjugates together and see what happens. So 3 times 3 is 9. 3 times negative radical 2 is negative 3 root 2. It's just like saying 3 times x is 3x. You just put them next to each other because one's inside the root and one is outside the root. Here you have 2 times root 3, which is a positive 3 root 2. And last you have radical 2 times negative radical 2. Those are both in the square root, so you multiply them together and get negative radical 4. So again, when they're in the square root, you can multiply them. When you have one in and one out, you just put them next to each other like 3 times x. Just like when we FOILed conjugates before, the middle terms are the same number, opposite signs, and cancel out. Negative 3 root 2 plus 3 root 2 cancels, which in this case leaves us with 9 minus the square root of 4. Luckily, 4 is a perfect square, so that gives me 9 minus 2, which is 7. So by FOILing these conjugates together, I have successfully gotten rid of any square root that was involved, which is exactly what I want to do when I am working with denominators. I want to get rid of square roots. Same thing will happen here. 25 minus 5 root 7, put them next to each other because one is in and one is out, plus 5 root 7 minus radical 49. Again, those 7's got to be multiplied together because they were both in the square root. Okay, so now positive and negative 5 radical 7 cancel out. Leaves me with 25 minus the square root of 49. 25 isn't in a square root, so I don't have to worry about it. It's still just 25, but 49 is in the square root. Comes out perfectly as a 7, leaving me with 18. Again, successfully got rid of all of the square roots, which is what I want to be able to do to this one from the bottom. If you look, this looks different than what we did before because of the fact that there are two terms on the bottom. Terms are separated by addition and subtraction signs, so there are two terms on the bottom. If I multiplied this by a radical 2, I would have to distribute that radical 2 to both terms, and I wouldn't get rid of the square root on the bottom. So that second term really throws me off. So what I'm going to do is I'm going to use the conjugate, because when I multiply conjugates, I didn't have any roots left. The conjugate of this is 6 plus the square root of 2. Same number, opposite signs. Whatever you do to the bottom, you have to do to the top. So if we start on the top, I'm distributing the 2. 2 and 6 are both outside of the roots, so just multiply them together. 2 times 6 is 12. Plus 2 times radical 2 is just 2 radical 2, because one is inside and one is outside, so you just put them next to each other. On the bottom, I have to FOIL these because I have 2 binomials. 6 times 6 is 36. 6 times root 2 is positive 6 root 2. Negative radical 2 times 6 is negative 6 root 2. Negative radical 2 times a positive radical 2 is negative radical 4. Again, those got to be multiplied because they were both in the square root to begin with. Positive 6 root 2 and negative 6 root 2 cancel. Leaves me with 36 minus the square root of 4. Luckily, 4 is a perfect square, so that leaves me with 36 minus 2, which is 34. If I go to put it all together, my top is 12 plus 2 root 2, and my bottom is 34. So I have gotten rid of the square root on the bottom. I'm almost done, but not quite. Make sure that the square root that's left is simplified. Okay? 2. I can't break 2 down any further, so I know that that is good. So then the last thing I check are the numbers that aren't in the root. 12, 2, and 34. And we see if those are all divisible by any of the same numbers. 12, 2, and 34 are all even, so we can divide them all by 2 to shrink that whole fraction down, leaving me with 6 plus 1 root 2 over 17. Remember, the radical doesn't have the same rules as the other numbers, so even though this was even, I didn't care. All I cared about the 2 inside was that it wasn't divisible by any more perfect squares. Once I knew that, I was done touching it. I couldn't do anything else to it. So I just got to simplify all the numbers on the outside, and that was my final answer. This one's a little bit more complicated because of the root on top. But we're still using conjugates. Negative 4 minus radical 8. Negative 4 minus radical 8. Top is getting distributed. Numbers on the outside get multiplied. Numbers on the inside get multiplied. So 2 times negative 4 is negative 8. That 5 is just in there. Here I have negative 2 radical 40. Because the 2 didn't have anything to multiply by, but the 5 and the 8 were both inside, giving me 40. On the bottom, negative 4 times negative 4 is 16. Negative 4 times negative radical 8 is positive 4 radical 8. Radical 8 times negative 4 is negative 4 radical 8. And 1 positive radical 8 and 1 negative radical 8 gives me a negative radical 64. Just like any other conjugates, my middle terms drop. In this case, leaving me with 16 minus the square root of 64. 64 comes out as 8. 16 minus 8 is 8. So I now have this for my top and 8 for my bottom. Check the roots before you start moving things around. My roots on top are 5. 5 is prime, so I know I can't break that down anymore. But 40 is divisible by 4. So I need to break that up. 4 and 10. The 2 is still on the outside. Square root of 4 is 2. 2 times 2 is 4. So that term goes to 4 root 10. So I now have negative 8 radical 5 minus 4 radical 10 all over the 8 that I had from the bottom. I already simplified my square roots, so the last thing to check is the numbers that are not in the square root. Negative 8, negative 4, and 8. Those are all divisible by 4, so I'm going to shrink them all down. So that gives me negative 2 root 5 minus 1 root 10. You don't have to put the 1, but you can. And then the 8 divided by 4 on the bottom gives you 2 on the bottom. And that's the simplified version. I'll do this one really quickly. I don't want to run out of time. But 3 plus root 2 is the conjugate. Oops. On the top, that gives me 24 plus 8 root 2. On the bottom, you know the middle terms are going to drop out, so just do the first and the last. 9 minus radical 4, which is 9 minus 2, which is 7. On the top, you only have a square root of 2 that can't be broken down, so 24 plus 8 root 2 stays the same. 7 on the bottom. 24, 8, and 7 are the numbers not in the square root. They are not all divisible by anything, so that's your answer. And that's it. First assignment of the day is page 590D, numbers 33 and 37 all.